Hello everybody, welcome to another stream. So today is going to be the final stream of the encoder system. Before we're going to move on to a quick and easy implementation of the asset system, because we just need something in place that just works really, doesn't have to be too complicated. But it will probably be more complicated as the game gets developed more. But the reason why... Oh, okay, wait. So we're specifically working on today is the code generation side of things for the encoder system with the CSON reader. I've already worked on a little bit off stream actually, but we should be wrapping up on that today and maybe getting started on the CSON writer. CSON is our C like JSON. After this stream, I'll just be exclusively finishing it off stream because, you know, you guys will get the hint of what's going on. There's nothing really special. It's just getting down in the weeds and solving small little problems and finishing it off really. So I thought we might as well just get started on other areas on stream, and I'll just wrap it up because we have been working on this for about 17 streams now, I think, and it's gone for a rework and a plan out stage all on stream. So I just feel like we've done enough of that now. So we'll finish it off today as far as we can and move on stream. And then we'll get cracking with the rest of the to-do list, basically. So yeah. Hey there, post Arnold. How's it going? How are you? So I found out in Helix that I can set an extension so if to be a certain language. So my .enc files are they're basically very C-like. They've just got a few extra bells and whistles on them. So if we do this .enc encdb, because that's the database file, it's very C-like, that should hopefully give us syntax highlighting in automatically without having to do set language manually. So I quit out Helix and reload it, then open up the file .enc. Boom, would you look at that? I don't have to do set language anymore. Cool. Rightio, this is good. So let's just take a quick browse on what I've been working on. So effectively, if we now go to we've got a C file, which generates some source code here. And all right, CSON, give it a quick show. Maybe I should make CSON as part of this as well. Yeah, that'd be a good idea. There we go. Yeah, so here's our C-like JSON. This is what it looks like, right? It's basically JSON, but it's got types everywhere, and it has dots before the fields, right? And they don't have to be in strings, and yeah, it's just like C initializers. So we parse this. We've already written a parser for it in the past. So we're basically code generating from these data structures that we declare in our enc file. We're code generating a bunch of functions which will read up from the CSON files. So I think there's one called test here. It's got coordinate, a vector3 coordinate. It's got an integer a and integer b. And so we look at here. It's generated that here. So it starts the structure. It's got versions as well because it's got the file target mode on it. So it's got versioning because it saves that to a file basically. And yeah, we read each field inside the structure in a loop, and we hash the identifier up, switch on the hash, and then either it's the coordinate A, B, or something that's invalid. So this is all code generated automatically inside the ENC ENC code generator that we've been working on over the past however many number of streams. So what we're going to do now is start work on the default initializers. So because in CSON, right, you could technically not have all the fields there, whereas if it's a binary file, the fields exist there. If not, it's binary incompatible. So because fields can technically not exist, we've sort of leveraged that and made it a feature where if it doesn't exist, you can provide a default value. And also there's many other things about if you encode that to text. If you encode that to a text file, you can basically add new fields, right, without having to up the version number. But you can't delete any. And the system will complain if you do that. So yeah, what we're going to be doing is writing the code which actually default initializes the structure, and it will code generate that. So what we're going to do, wait, do we want to do that first? Yeah, I think we'll start off with that. Actually, we'll come. Yeah. We'll come back to this. We'll just do one quick task beforehand, which will prepare us for it, and that is the. We're going to clean up the. We're going to add something new to the structures, I think, or the structure fields. So if it's a packed type, you want to know if it's a bit field index, and then maybe the bit start index, and the bit start index. So this is for the packed types, basically. And we should probably work that out and retain it, because right now we keep working it out on the fly. And it's good if it's just stored in the type information. So when we do some code generation, we don't have to keep reworking out the state, and it gets a bit fiddly. Hey there, Campaign. Did Mix Helix work? Not that much. Work, I just get down and do work. In Visual Studio, I've been using it for like 3 years now. Visual Studio is alright. It is slow. You want to try and search for a file, you press a few buttons and it takes a number of seconds. Whereas in Helix, it's like, and I'm typing away, find my thing. But yeah, not super missing it, but there have been times where I get just get really frustrated with Visual Studio, though. It would be great to make a switch one day, but it really just cuts into doing actual work at work, and I can't be bothered to set anything up in my spare time. But yeah, maybe there might be some time where I can migrate over. I'm getting more productive in Helix now. It's taken me some time since I only do it a few times a week. But yeah. And hello everybody, I hope you're doing well. Hope you're having a good weekend. How's it going, Campaign? You doing good? Have you mastered Vim yet, Campaign? Are you a Vim master? So the first time where we do this, I think there's something called next bit field index. This is when we're already code generating some stuff. So I think what we'd like to do is before we call generate, you see, is we should probably have a thing which says so we just go over every single type and we'll calculate bit fields, we'll call it. And yeah, just be something like that. Alright. So we find where we do it the first time around. Seems pretty sensible. See if we retain those. It's not really going to help us with this, is it? But it might help us with the next one, right? Boom, doom. Do, 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 do. Yes, this one we'll leave it alone. This is where we will. Right, so we take this logic here. You know what, we need to just go all the way up here like this. Right, I'll do. Right. Let's get in there and okay. So we're going over all the versions. Oh, we need a file. Yeah, the file is the database. Yoink. Right, so go over all the files, go over all the versions in the file, right? We'll get rid of all the printing crap because we're not generating anything here. Then we simply go over the versions. Skip this because it's not to do. Wait a minute. We only want to work with structures because they're the only ones that can have packed types. Maybe we want to have an enum to say if it has a packed type. I haven't got that. It has bit fields. Could be labeled a bit better. But yeah, so if it doesn't have bit fields, we'll skip it. This emits the data structure. This is not the one we want. What we do want is this one here. Right, so next bit field index, next bit index, go over all the fields, and we're going to basically check if it's packed. Well, those C++ packed types, which you specify min and max bounds and the number of bits you want to squish it down into. And yeah, so effectively we can delete all of this. We're only looking at keeping when we increment this, basically, isn't it? Right, here's the bits count. So we'll do like next bit index plus equals that. And inside, see, should we go inside the packed section actually? Let's go back to that type thing that we was looking at. So inside the type, I did squish them in here somewhere. Where was it? It's the hang on a minute. Where did I chuck you? Bit field. Did I undo them accidentally? Seems like I did. Oh, I don't know what happened there. Right, okay, back to that type. So inside the packed type, this is where they're going to go. So it'd be like bit field index, bit index. Oh, I put them in the strut field, didn't I? I see. Yeah, we'll keep them in there. Right, so bitfield start index equals next bitfield index. And then like, we could say next bit index. There we go. So we up it. So we up it here, and then we do that super lovely check. No libraries at all. Hey, no idea. How you doing? Good to see you. No libraries at all. Well, use a few, right? So B stack trace. So we do stack traces at 400 lines. Give it a search. Single header, pretty nice. STB image right, image STB image, rectangle packer to pack our glyphs, and STB true type. I've written one of these in the past, but I wrote it in Rust when I was doing my Rust stuff, and I couldn't be bothered to do one again. And then my custom C compiler for shaders as well. That's another third-party library. Yeah, so that's about it. The rest is all just written for this project, really. But yeah. Doing good, gonna have an anniversary dinner tonight. Wow, happy anniversary. And now I gave up on the I'm just using VS Code. I'm just a VS Code guy. Fair enough. That's cool. Yeah, NVIM is quite the commitment. What's your advice for beginners at programming? Just get started, just do it, enjoy it. What do you want to do? What do you want to get involved in? Bit better, still amazing, but I feel like it's time to start writing an engine. Oh yeah. Keeping UI on pause until I need it because I don't feel like I'm dealing with rendering stuff. I don't feel like dealing with rendering stuff and back-end stuff. Cool. That's all right. Yeah, when you really like need something, you really just get your butt into gear into finishing it, right? Because you want to use it, you know. But that's cool. Amazing. Like an engine. What type of engine you want to build? You want to build like a general engine that is like 2D or 3D or like for a specific game or something? I start with the UI when I started to port it to software rendering to OpenGL. Yeah. Yeah, I remember that. Yeah. Mm. And you did OpenGL because Vulkan didn't support something, wasn't it? There was a specific thing to do with the drawing on the old swap chain image or something. I forgot what it was. There's a technique to. I forgot what it was now. Right, so what we need to do now is up the bit field, next bit field index by how many times this could be next bit index divided by the words. Have I got this dot about somewhere? Come on. Yeah, there it is. Right, let's plop that in here. Alright. Right, so divided by the number of words for a bit field. So if it's just a 32-bit uint, divide by 32. Right, so if the next bit index goes 32 or above, it will then divide. And then what we would like to do is mod this thing. And I think that's like a single instruction in x86. I forget these things. But you can do a division and get the mod as well in one op. Anyway. Yeah, so that will then wrap this round to 0 again, basically, when it overflows. And this will also count for multiple times of wrapping round. So if you made your bit field word index a byte and your thing took up 24 bits, it will go over multiple bit fields, and this thing will account for that. So I've just basically cleaned up the code. So rather than working out the bit for every structure field, which is a packed type, aka a bit field, we store the actual start index inside the structure field now, versus trying to recalculate it every time. So that's a good idea. So we can carry on with some code generation new, I think. Well, we've just got to clean up some other bits now. So I guess, right. So I'm trying to think of the logic when we code generate the struts. Because we need... Yeah, I think we'll keep that logic. Okay. So when we generate the structures, we actually did this thing where we work out if I show you the generated file, it just makes a ton more sense. So, here we've said, hey, this entity type has every bit field is a U8, but the word size is a U8, just for testing purposes. Probably a terrible idea to do that, but just for testing purposes. So we've got a few packed types which get packed down into these, and they can span over the word size. Each bit field can actually span over the word boundary as well. So the code that Will's looking at actually works out where to stick these bit fields. So I'm going to keep this logic where it works out from the beginning again by starting off at 0 and going over all the fields. When it comes over a packed type, it will just rework that out, and that's okay. Yeah, that'll be all right. But it's just the bits after that. This is when we generate the so go to the ENC file. These are our packed types where I've got U16 packs into 9 bits between this range. Right, it's just testing code. Doesn't have to make too much sense. It's got some enums that get packed down as well, and floats as well. And these generate a .h. These generate this super lovely unpacking code. So this is the code that gets generated from the code that we're looking at. So it deals with floating points, it deals with enums and integers and things. this was calculating the bit field index and the bit index from the beginning again. And now we've pre-calculated that data and stored it inside the structure field. We're just going to migrate it to that. And that will help us in the future when we want to do more things like this. Because I think we want to do some setters as well. And we want to do default values, and default values have to set these fields. So they have to recalculate it every time. It's just a bit error prone doing that. So yeah, all right, let's have a bit of a catch up. Not really because that, but Vulkan is complicated for reference back and renderer. I wanted to keep script minimum. Cool. I have a question for you. While in your stuff, I've developed the need for dynamic arrays and hash tables. I've created my own solution, but it's not the best performance, but it might be okay. So I wonder how you deal with that in C. Since in a templates in C, doing macro genesis is crazy in my opinion. Yeah, I think it's a necessary evil though. And hey there, Downsy, how you doing? How's it going? My moderator has returned. How are you? Oh, my hair is so long now, so it's sitting on my eyebrows. Welcome back. Welcome back, sir. How's the family? How are you doing? Yeah, so basically, I leverage kind of a Clang extension, and it's really actually C23 to do my dynamic arrays. My dynamic arrays. So here's the thing, right? Templates are a thing you can get carried away with. So I much prefer a language that doesn't have templates, but allows you to do template-like things in a dirty way. So that means I would be ashamed in doing too much of it. You know what I mean? So that's why I kind of think macro template stuff is a necessary thing, right? So what I do is I call my global arrays a stack. I think the name vector is terrible. I think the name array is misleading. So I picked stack because you typically push and pop on it, and it's contiguous. So my arrays, you allocate them once, and this makes the API a lot more simple. Push doesn't magically allocate any memory, therefore I don't have to worry about storing a custom allocator in here. If you look at all these new age languages, they stick a custom allocator in here, and that's like 2 more pointers. And really you can have a bunch of like stacks next to each other in a structure, all with the same allocator. So you're basically wasting 16 bytes per one of them that are next to each other. It's just a whole load of crazy sauce. So I think I like this approach. What else have I done? Yeah, I made the typed one a union so I could get the void stack out just by doing an access rather than casting it, basically. It was just a bit easier. But yeah, we generate a typed one so you can declare, or declare it, and then you can define it. So you have to use the macros to define it. And then with a C extension, type of, you don't need to code generate anything with a global array. With hash tables you do, because you want that type safety on a few functions. With global arrays, you don't need it at all. Global arrays, if you're willing to use the type of extension, which is available in C23, you can basically do a type of, when I do a push, I have a push many, which is the actual function, and it's just one implemented for that covers every single type. It's just bumping a pointer, bumping a count, grabbing the end pointer, bumping the count, and then returning the pointer. Very quick and easy. No constructor crap going on that you would have to do if using C++. So all I do is push, I get back a pointer. The pointer is automatically casted based on type of, right? And then I I can basically deref it and set it right away. The assumption is that this never returns null and this never allocates any more memory. It will assert and crash if you fill it up, right? You can also insert and remove. We've got a swap remove and a shift remove, so you can choose your preference there when you want to remove. And that's basically how simple my global array is. Oh, you allocate on push. Interesting. Yeah, so the problem when you allocate on push is you either have to pass in an allocator here when you push, or you have to store the allocator inside here, or the allocator is global because yours is a library, then you can probably just have one global allocator the user can override, right? So I think it's probably a good approach. Yeah, if hash tables are basically the same thing, but I end up in my define, I actually code generate a couple of type safe find or insert things, because I would like to pass it in by value. It's inlined, but then I take a pointer of it. Yeah, it's just so there is some stuff going on here. This static assert is there so I could put a semicolon at the end when I use it. That's all that's there for. If not, it's basically the same thing. It's just void implementation. That's what I really like about the C version as well. When you do it, you don't have many versions of the same function implemented, really. It's all just one function that can just be shared for every type. How do I do custom types? I have so it's an anonymous structure of key value. And when you declare the type, you got to declare the hash table type. You pass in the key value, and we literally just put it next to each other in a strut like that. So we don't have to declare another type. And then whenever you call your functions, we pass in the value. The key offset doesn't have to get passed in. We just have to pass in the entry size, and the value offset when we need to get the value back out. And this is all done automatically via the macros. Where are the macros at? Oh, we don't have macros for these ones because they're functions. But yeah, the macro. Yeah, these ones are. So we work out the offset, but in offset of with the strut, anonymous strut again. That's the value offset. And then obviously we do size of here. So we never retain that information. We always just pass it in to these functions. And that's how I handle it here. But yeah, does the job. Yeah, it's pretty alright. It's a shame that I do require type of for the global array, but it is becoming standard in C, so it's okay. Good, thanks. Wrapping up on a load of admin. That has occupied much of my year. Fair enough. Booked my flights to Japan. Amazing. I got on holiday next spring. Cool. First trip in many years. Yeah, flights got really expensive after COVID. Me and my wife went on a holiday. Sorry, on our honeymoon. Yeah, like a couple of years ago now. That was we spent like $5,000 on flights. It was a lot of money. I went to Zimbabwe. But yeah, I think they're still up obviously, but yeah, they shot up like crazy. That's cool. Japan sounds amazing. I've never been. I've not actually been into Asia. So we should probably go at some point. Be good fun. You don't need the type of, to be honest. Why not? Because if I don't have the type of, then I can't do this. Stack push dereference, right? I wouldn't get the type safety, so I can't do something like, this is, I don't know, so some value, right? I can't do that. I'd have to cast it beforehand, and then also I wouldn't get the error if I got the pointer wrong, basically. Yeah. So the type of is there because it's kind of helpful. Right. Yeah, 4 GB. Yeah. You saw the allocating the element size in the upper bit. Oh yeah. Yeah, that sounds alright. Yeah, I did. Yeah, I've done something like that in the past when I've done my own library thing as well. Yeah, that's not a bad approach. You can use like indices to represent the allocator. Yeah, that's alright. It's not a bad approach. Yeah, I was considering a U32. Maybe I can swap out to it at some point because I may never need it. That's a lot. It's a lot of values, right? 4 billion values. Yeah, three of us economy class for 6 grand. Oh my days. Returns from London, Tokyo. Oh, ouch. But we're going to, in time to see cherry blossoms, so I would expect it was contributing factor. Rightio. Mm. Yeah, we went to Australia, and yeah, that was another expensive holiday. We just finishing paying that one back. We went in February. It was, yeah, good times though. But yeah, can you believe, right? The government, right, in all their wisdom, they want to ban. Well, this was the old conservative plan, which is crazy to me. Anyway, 2040, they wanted to ban the airports until technology came which saved everyone from CO2 emissions. And they were saying it would be done by 2050. That was the forecast. It was like, so no one will be able to go on a holiday for like 10 years? Anyway, it's just funny. Um, my allocator are very few, and I need, yeah, the index. Yeah, because in the library you could just, yeah. Nice. Very cool. Right, so we have these, we're generating these bit field extract functions. So we're just going to swap over to the new, we store the bit field index and bit index inside the structure field now. So we're just going to swap over for that one. So this code here, emit the utility functions. CO2 emissions where the government wants to spend billions on carbon storage when they could just plant trees. Yeah. Yes. And where also the government wants to sort of get rid of you know, move all the jobs outside the UK to other countries and be like, look, our CO2 emissions are down. Meanwhile, we've just moved it off to another country somewhere. You know, just proper stupid stuff. You can get rid of type of if you're okay with the hacks. Yeah, I want to keep it because the type safety. I do like the type safety, to be honest. But yes, the government. One day we'll be saved from the government, maybe. Maybe. But yeah, sounds cool at Japan. Sounds interesting. One day I'd like to go. Yeah, I hope you have a good time. But when are you going? What month are you going? On next spring. Next spring, amazing. Right, so packed type. Okay, so Interesting. Right, so then we'll do next bit index. No, this is so damn error prone. Let's wrap this in some brackets because it's got some local variables I do not want. Or a local variable that I do not want. Move this one out. Right, so the problem is that we will need to advance okay, that's all right. So this is the source bit index. That's what we should call it. So, all right. Right, some rename error. All right. So source bit field index, source bit index. That's good. Rightio, so we'll follow these around. Source bit index. Source bit field index. Noise. Source bit index. Right, so that's all been refactored now, so we don't have to recalculate those the bit field start indexes and all of that every time, which reduces bugs probably in code. That would be good. Right, so we do it down here as well. So here's the thing, right? I got this bit field initialize function. Let's go to the generate code so we can see actually how it looks. So I made this off stream as well, where it takes in all the bit fields and then just packs them down and then returns you a structure. Now this is kind of what should I say? It's great because you don't have to clear the fields out before, but the problem is it returns the whole structure. So, you know, I can't pass it in via pointer because if I want this to work on GPU, I don't really have pointer support in my compiler. So we can't really leverage that either. So I was looking at using this on the GPU maybe in some places, but it might just be a good idea to just make the set functions, and those will just have to clear the bit field out, the bits of the bit field out before you OR the field on. And I think that's just the way we're going to have to do it. Yeah, it's possible. So why don't we just make those instead? I'll delete this one. And then that way it's going to work with our default initialization code, because then we can just use those set functions where we can set each field that we're bit packing, right? So yeah, we'll do that as well. Right, so that's going to generate the bit field extract functions. Then we might as well do it the other way around. Now, okay, it's going to be a bit fiddly, but we can do it. So we'll do another one where we'll do... Maybe we should... Alright, let's put this in another scope. It's going to push it more over, but oh well. So this one would be the bit field. Nice. Extract bit field. Insert. It's not really insert, it's more like bit field. Store. Load and store. Right, this is the logic where it does the packing stuff. So I think if we take this, it'll be quite easy to figure out the rest. So here's the function generation, function prototype generation. So we just plop that in there. So that will be struct. This actually returns a value here, so it's a void. But we would like to put that here. We call it value. So type snake case field identifier underscore set. Type generated name, so it's camel case. Point it to it. So I guess if we're doing GPU, this might have to be a macro. We could make it a macro anyway. Maybe we make it a macro. Thanks for that, and March, stay for 3 weeks. Amazing. Hey, said who? How are you doing? Is that a saber? Hey, yeah, Vulkan. Can you Vulkan? What about Vulkan? It is the best worst thing we have in computer graphics. Oh yeah, Nick Johnson. So if we make this a macro, we can actually use it in on GPU without having to do a pointer version and a non-pointer version. But the non-pointer version wouldn't even... How would that even look? Because you would probably pass the thing in by value, then return it by value. It would just be bloody weird. Or you'd make a whole function which just constructs the whole object as we've just done below, basically. So we're just going to make them a whole bunch of macros, I think. And yeah, live with that. So let's take a quick look. So we'll be doing something like this as a macro, right? Obviously there won't be no return. So it would just be a bunch of this sort of logic inside. Yeah, that'll be right. So we'll you pass in your object. So here we go. It's gonna be lovely. Filled with backslashes everywhere. But this is the way. So you pass in the value. I typically like to do macros like so. A tab, it would be a tab, wouldn't it? Yeah, then they have a backslash. And obviously a new line. Tab. New line, tab, I guess. So what are we looking at? No, we don't do any tabs here. So, right. So I've got to convert this over to the new type of code, which will end up... So because this is the storing side of things, these will be the destination. So what it's got to do is got to extract that, it's got to take the value that you pass in and then store it inside the bit field. So these need to be destination instead of source here. So inside the structure field, we've got the start bit field and the bit field and the bit start index. Your value can span over multiple bit field words if you wanted to do it that way. Probably a bad idea, but this thing, the system supports that. It supports it going over the word boundary of the bit field. So we can get some really nice packing, but obviously you pay the cost of it spanning a word boundary. But it's clear and easy how you can avoid that. You just count the number of bits. It's the same if you are trying to avoid padding in a structure, right? You just count how big the fields are and you can work out where the padding is quite easy. Right, so this will be DST bit. So shift in this case shall be replaced. DST bit field. Wait a minute, in that, did we up the count in that? Yeah, we did, we upped it here, that's good. Alright, so we just keep going. So the next one is shift. Shift is going to be the destination bit index. And then after you've done it the first time around, if it's a float, you got to do a bunch of like, get the range, get the scale the value up so it becomes an integer that can then get, so then it converts to an integer and you're packing the integer into the bit fields. So that's why it looks a bit weird. Then simply here we're just going over all the remaining bit fields, because here it could have basically spanned over the end of a boundary. If it hasn't, it will stop, but it will just keep going and packing into the remaining bit fields if it has done that. So that'll be, these will all be destination. This will be destination bit field. And then we're removing that shift thing just because it was kind of a bit silly doing that. So it's the second shift in this case. Destination bit index. Rightio. So I think that's the code we need. We might need to close the, well, we're not really closing the function anymore, we're closing the macro. And we've got to put a bunch of backslashes on the end of lines so that it carries on the macro thing. So, righty-o. So every single time we see a new line, we've got to replace it with a backslash new line. So let's just quickly find that one. There we go. Hang on a minute. Because it's a macro, necessary evil. So we're going to quickly give that the generation. And oh no, we're gonna messed up. So I think we'll remove this initialize function now. I don't like the idea. We've got the set macros now. They do the job. Work across CPU and GPU without changing any code. And yeah, so let's go to test generate .h. So now I get see them in action. Give it a refresh. So they're pretty close. We need some extra tabs and things, and we need to actually double check and make sure they're all good. They're missing their type name, we probably didn't set the context-aware printing, which is set somewhere. Rightio, I think we messed it up there, wasn't it? So we've got to quickly grab that one. And then make sure we initialize these correctly. Alright. Oh, then we wanted some extra tabs. Why so much Vulkan hate? Because I live through it. It's so Vulkan's like a love-hate relationship of mine. It enables me to do some good things. The API is just so damn overcomplicated. It doesn't really teach you much about GPUs. If you want to learn about GPUs, you got to go elsewhere, right? Vulkan should be the thing which teaches you about GPUs. It doesn't. It's some abstract thing where you're like, so why am I doing this? And the API is also just so overcomplicated. Whenever you do anything, there's like 17,000 things you're failing according to the spec, and you got to go and fix all of them. And then like you wouldn't even realize all of them because you got to trigger all of them manually. And there's just so many. Like it's like death by 1,000 validation errors. But you know, you can do some cool stuff with Vulkan, right? It's just such a crazy complicated API. Basically. So there's a few places I recommend learning more about GPUs. I'll give you 3 tips. First one is the Mali GPU training series on YouTube. They teach you about, for crying out loud, get me to the playlist. Yes, there's a playlist going over about like how GPUs work, desktop ones and mobile ones, what the differences are, and at kind of a high level about the hardware. What things you need to think about when you're actually learning about Vulkan, right? The other thing I recommend you do is read the RDNA 2 or RDNA 3 ISO documentation. 2 is not too different from 3. 2's also got a load of other resources which is useful to read that go alongside this. But yeah, teach you the instruction set architecture, and like it even has diagrams about how the GPU kind of works as well. And then you also would like to another thing as well is if you could get hired as a graphics programmer where you make games for consoles, the hardware is a lot more, the documentation for it is more open and available, so you'll be able to sort of understand how a single piece of hardware is implemented a lot more. And then once you understand that one, it gives you a general idea of like how other ones can also be kind of similar as well, right? So it gives you a window into that sort of world a bit more detail. So they're the 3 sort of ways I recommend learning about GPUs. Yeah. That's the price for power. Yeah. I don't know. I think I really do. What I like about Vulkan is the API does seem like the way they've done the way it's like written, like it follows like a coding style, and it feels like clean. It is a bit it's a bit like verbose, but it is very sort of clean and nice in that regard. It follows a convention, the way it just is designed, it feels kind of coherent. Although when you look at the ray tracing API, you're like, come on. Like that one's another one. Just the ray tracing API. Oh my days. Talk about abstraction. That one is nuts. But yeah, I think we could done a better job though. That's my concern. It's like maybe give us more access to the hardware directly. We should probably minimize these high-level abstractions that we have. It'd be great if we had more direct access. So let's go to generate H file. All right, so I got generated properly now. So we're taking the object. We should really wrap every time we use object. We should wrap it in a wrap it in some brackets. And I don't really seem to be using object right now, which is really dumb. So where we say ret is actually going to be object, and then it needs to be an extra new line after these things have ended. So there's a few things we have to do. Every time we do a tab, we need to do a double tab. All right, then every time we do a ret, we want to replace it with ob wrapped in brackets. And then we simply just want to have a little look and make sure we've done it all right. So this will support pointers and non-pointers. That'll be pretty great. So, I did call it value. Here I'm saying strength. So maybe so here we're just doing like a little clamp. So maybe we should do the clamp, then take 100, store into the local. So all right, here's my plan. We put a P after it, isn't it, or something like that, for some reason. All right, so I don't put the P there. Why do we declare it? That's here, isn't it? So instead we label it to value underscore underscore or something. That should help us avoid. Yes, that means this can be joined. I get deleted. Oh yeah, DST bit field, that's right. Alright, so that's pretty nice. Anything else? Right, there's another one down here. Value underscore underscore. DST bit field index. Right, so, right, let's do that. So if we rerun that. Right, so we've given it this sort of name, so hopefully it's distinct. And it's the word strength in there, isn't it? Right, what do we do? It's FI. So we got to be careful. We do $FI. Well, we could just make this $FI. Any problem with that? I'll do it. Right, so that we've checked the integer one. I think integer one is just fine, but yeah, so rightio. So here's the strength when we read it back. That is not a macro, but then when we store it, it is a macro. You know, yeah, we can't really make the, well, we could expressionify this out like crazy, probably, and then make that one a macro as well. And then we don't have to have a non-pointer version for GPU. That could be a thing that we do. So set. So the problem is this will end up overwriting. Yeah, so I want to make sure we bring this down to here because this could be like some access into some field, some structure field somewhere, and you've just basically set it in this thing. It's a bit weird. So yeah, we want to move that clamp actually down to a like that. So this one here ends up actually doing some of these things. We should probably call it like a value f, to be fair. So that value f underscore underscore, and we're going to be setting it to like a clamp. Well, clamp, then a minus, then a and then value is just value f casted. Alright, yeah. Alright, I think that will do. Alright, so let's give that a regen and take a look. Yeah, so let's put that all in one line now. There isn't any funny business going on. We're just basically getting value. We're taking the value and clamping it between the ranges that you say, take away the min, got the value, and then we're packing it in there. This one takes up the whole of bit field 0, right? And it's 9 bits, so it ends up taking the first bit in bit field 1. Wait. Yeah, by shifting this to the right by 8, so you're left with the 1 bit, and in the 1 bit, then shifting it left by 0 since it goes into the first bit of here. Yep. Obviously, these don't have to be here, but they'll get optimized out. Cool. So that seems pretty all right. For the integer side of things, let's see a floating point example. So here's a floating point one that spans across a couple of fields as well. This is the read. So it stores from, starting after this strength field is this range field. It's a float. It will start from the second bit, and then it also will do 4 more bits in bit field 2. But there's 7 bits here. So yeah, it shifts it left by 7 and ors it on. Yep. So then it, descales it back to a float and then adds the min. So that really should already be floating point though, but oh well. That's going to do a damn The problem is when that's not casted, the compiler's going to be like, this is a double, and then it will probably make it a double and do an add. So realistically, we should actually like we should put that cast in there so the compiler doesn't try and follow the standard too closely. So yeah, they'll now do the add as a float 32, not 64. Right, so the set is going to do a similar thing. It does it the other way around, right? So we clamp the value passed in first between these two. They'll get casted to a float, so that's okay. This is a double though. I want to get that casted to be fair. We can do that. Right, seems all right. Scale it, cast it to an int, then pack it down. So this gets packed down to the same places, right? We've taken the seven bits, and then we're shifting it left by 1 and storing it here because it starts on bit 2 of that bit field, and then this one takes 4 bits from the start of this one. Yeah, okay. That seems all right. So I'm happy with these now. So we've got some getters and setters. My concern though is actually this one is still a function. Maybe it is better if we just macrofy it. See, the problem is with the doing macros is that we will just copy pastes the code basically, but it's all right, I think. But at least it's forced in lines, you know. Yeah, so we might macrofy it. Let's just double check for a sec. The problem is if we macrofy it, this will just become absolute crazy source, right? Because this scale is going to, like, these are definitely like constants, right? So that'll just compile that. This could just compile that to a constant. And then this extraction as well. So we could just put this in brackets, do the extraction code, and then scale it, add the thing, and that will just all be inside a set of brackets. It's possible. One of these always in line, because it's not about inlining. The problem is that it's pointers. I want this to work on GPU as well. And I don't have pointer support on my shader compiler. So I want to convert this to a macro, I think, because then I don't have to maintain 2 different versions of the generation. We could just make it always be a macro, and it will support pointers and not pointers, stuff by value, that sort of thing. Gonna prep dinner. Have a great evening. Good to see you. Dazzy, have a good one. Hey, glorious sir. Not doing bad, my friend. How are you doing? Yeah, doing good. We're just doing some refactoring of the bitfield extract code and then getting back to the CSON reader side of things. But yeah, doing the final stream of the encoder stuff because I think we should move on to some other task on stream, and I'll wrap this up off stream, I think. But yeah, things are going good. How about you? I put up the baby gate now, so the baby is now safe, crawling up, won't crawl up the stairs anymore unless he's supervised. That's what I got done yesterday. Also went out for a meal with my wife. Ate some salt and pepper squid and a nice lamb shank. Nice tasty, tasty meal. But yeah. Also ate some KFC today. First time in a while. Was pretty good. Lovely, I'm fine. Awesome. How's the projects going? What stuff have you been working on lately? So yeah, let's butcher this code and let's convert it to macro. It's gonna be fun. So this one cannot be made like, yeah, it's gonna be pretty nuts. So basically, right, let's boil. So scale is made from these three lines here. So let's just, and it's a constant. So let's just make it a constant and replace that with the constant, and then we'll go from there. So the way we work it out is we get the range. The range is this one. Ooh. Not the store, get out of here. The load. Wait, this is only if it's a float. Rightio. So there's our range. Now, it may or may not be a... It's a float or a double, right? So we'll... Sure it's double. This is our range. We also need the max value. Max value that fits in the number of bits. Rightio. What else are we doing? So then to compute the scale, it is simply, in this case, this way around because we're loading, it is range divided by max value. So that's the constant that we're going to be packing in. So we're then going to pack it in right here. So we actually need to break this into a... So we'll cast the constant, and this is where we'll put the pin in it. This will be left for another... print format later on. Then we are going to do a fprintf and use the format stuff. Maybe I could have just made mine do the formatting thing as well. Like that probably would have been a better thing in retrospect, so we didn't have to break things up. So here we're looking at basically putting in the float value. So that'll just be scale. Maybe I could have made that like a $S, and it could have automatically calculated it. Oh well. What makes the code gen better, doesn't it? Yeah, let's do this. So $PB, $PS. So we find that print format thing for the B. Right. This is the pack type one. Simply we're just going to fprintf a scale like that. Right, so these are the types. Gen format type. But that'll work nicely, so let's look for the PS now. Cool, and make sure we set, that is set here, the format type is set to that packed value, that's good. So that should, we regen it, go back to here. It is using the macro now, so it's a little bit more, oh no, sorry, it's not doing it yet. So here's that scale, it's all pre-computed. We don't need these fields here anymore. Where are they? Yeah. Cool, so to reduce it down to macro, I've got to get this down to a single expression. So what's left is, let's make this ret. Was occupied by uni stuff mostly. What went on a change shaded language trip because slang was mentioned in the Discord and ended up using HCC to learn some remarching. Oh, awesome. Cool. How are you finding it? Yeah, that's pretty sweet. It's a lot of fun remarching. I think actually I've been considering actually doing some remarching for some of the rendering stuff. When we get back to doing it in like a year's time. It's one of my thoughts currently. Is doing some remarching for some aspects of the renderer. I'll still stick to rendering ellipsoids, but just other effects. That's pretty cool. Have you got any pictures? Any images that you rendered? Right, so basically what we'd like to do is wrap this in a bracket. So wrap this whole line in a bracket. And then put another open bracket. That will then encapsulate these two things that will get all together. And then you want to close that bracket and then multiply it and then add the min. But then for obviously for this one, I will just add the 100 there for integers, right? So it shouldn't be too bad. We'll change it to macro in a bit. Let's just get it working. So we just want to wrap the whole thing in a bracket. We get rid of this ret thing. And then that'll do the first extracts. Then if there's any more, it is simply going to OR itself on. But anyway, we should have closed a bracket here. Opened up an extra bracket, yep. Then this one is gonna open another bracket and then close. Nice. Then when you've done it all, you close all the brackets. Get rid of the semicolons as well. That's done. Then when we're done doing it all, we close another bracket. And then we simply look for a... Right. So if it's a float, all we're looking at doing now, let's get rid of all this tab crap. We're just simply looking at... Wait a minute. We've got to cast it. We've got to make sure this is casted into a... overall casted into a float when it's done. No? Yeah, cast it into a float when it's done. Yeah, we could do that. Then multiplied, then added. Something like that. Whereas here it's just an int. We just want to basically add on the min. So then after that, so we probably want to overall wrap it in another bracket. because it's gonna be a macro. I guess let's change it to macro as well. Just get it all over and done with. So we'll probably be using something like this. Yeah, so it's basically about the set because it's a read, no values in there. Right, so you don't make a local anymore, but we do kind of need to know, like, what is the right, something we've got to be really careful about is actually U64s when we're doing all this shifting thing, so we've got to remember that one. We'll come back to that in a bit. But this one is only shifting out. Nobody could shift it. We should probably always cast it to a U64 when we're doing these shiftings and things, but we'll get to that in just a bit. This one's talking about... Right. You wouldn't need that anymore. At all. Right, so these need a few little tabs. We don't need these brackets actually, just a tab. You know, it would be nice to maybe like, you know, open that one onto a new line. So we'll put the bracket here. A couple of tabs. Then whenever it does these, it's going to do the OR. And then it's going to put on a new line. And then it's going to tab it in a couple of times. And then do another one of the bit field extract things. How's that looking? Yeah, and then on the final one, it would want to do a new line. And then tab once. I think that's not it. New line, tab. Oh my days, it's getting crazy now. Tab twice. Right, I think that's it. Kind of crazy, but hey ho. It's macros for you. Right, kind of messed up just a little bit, but I think it's there. So basically, right, we've got to make this because it's a load. We're just extracting the value. Maybe I call it load and store rather than yeah, I don't know. So open bracket, open another bracket. These are the bit actually extracting the bit fields and oring them together. So I was hoping that would have had a bit of a space on it to be fair. And then this one's obviously missing the extra tab. Got to change that. Right, is extra tab. Then I want to put an extra bit of a little space there. And then I think these might also want a... Hang on a minute, what do we do? Yeah, this also wants a bit of an extra space as well. You know, make it a little bit nice considering it is a horrible macro. Alright. So, there's a lot of brackets here. Alright, I was hoping that would have been a... That's not good. So we did accidentally mess up here. This should have had another bracket. Right, so yeah, this is actually extracting the bit field, then it's in the scaling thing, and that all fits on a single expression. So we can use it CPU side and GPU side with and without pointers. The problem is here though is I'm not actually, like, this is expected to be a pointer, it's not being wrapped in brackets. That's the other thing we've got to fix quick. Let's press this OBJ with a pointer. Do a nice quick little adjustment there. Alright. Sense compiler spewed out some weird Vulkan restrictions nonsense to me for shader that certainly didn't need them. Experience HC was super smooth, couldn't use it on Win32 path because some of the relative path crap, but was otherwise fast and does well any task. Awesome. I'm super happy with how clean the binders looks. Yeah, that was the main thing about it, is that it was very opinionated. Because that's the problem I found with the shading languages, is they were just very sort of like historically they were historically shaped, and I thought it would be good if we made ours sort of just be a bit more modern and ditch some of the old stuff. You don't have to manually declare like how your descriptors are. It's very opinionated. The descriptors have to be this way. Oh, and when I read SPIV and compare it to GSS SPIV, I was super confused with Phi, but then in the end, yeah, the single, yeah, SSA, singles, yeah. I have super cloudy shape animation, but I stopped there to understand maths behind it, right? It was pretty boring. That's cool. I'm glad you enjoyed that. I don't know what happened with the relative path thing though. Huh. I can use it with the Win32 path. Huh. Yeah, I'm not sure what that's about. Can you expand on that at all? Because yeah, not sure what that means. But yeah, so I think we've adjusted these now. So our bit fields functions, right, or the macros now, I think they're pretty good. They're going to work CPU and GPU without an extra code path. And I'm super happy about that. So let's get onto the default initializers, shall we? So text files, or our CSON files, have support for default values because because it's text, they don't really have to adhere to a very specific structure. You could technically have fields missing, or you have fields missing from here, right? Whereas with binary, it'll break the ABI compatibility. So we leverage this in the encoder system, where we say, hey, you can actually like always add new fields without upping the version number. But you can never delete fields that have already been generated within the past unless you undo some stuff in the database and hack it. But that's a bit dangerous, but you can still do it. So to solve this problem, when you export to text, you can specify a default value. Default values are by default 0 for the most part. Or you can specify anything you want here. The parser will parse up as a string, and then I'll just paste the string in as code when it generates it. So that's what we're going to work on today's actual generation of this. We're going to generate some default value thing function, which will construct a default value for the maybe we don't really make it a function because then someone else could use it. and it's only really meant for the CSON reader. And I haven't, because if a binary makes no sense, I can't really think of another use case. Like, you could just put default values in there and just have a function that gets made to construct a default value. Um, but the whole point of this, I think, is oh yeah, I think matrices are default value to an identity matrix. That's the only thing that's not zero. Um, yeah, so refreshed. So yeah, not sure. Not sure. For binary, for the GPU, could it be useful to have default values for things? You know, I'll just be making a bunch of functions that we might not be using as well. That's another thing. You know, because if you don't put text there, we don't actually need the functions, right? We might not need the functions for everything. So for now, what I'm going to do is not create them as functions. We're just going to put them directly in the reader. So this goes to the generate code. So here's what the CSON reader stuff looks like. Here's there's a let's quickly see the strut. So here's the test strut. It's got a coordinate, A and B field. The integers, one's a vector. So whenever we use this reader thing which we made in the past, we read the compound literal bracket things with the name of the strut in there. That can fail. If so, this will return null and then break. It will report an error internally. So we've got ways of backing out of this quite nicely. But yeah, reads the identifier, hashes it, and we just use a hash to compare things and hope they're unique. If they're not unique, the compiler will complain, and you can always choose another name. So that should be quicker than just comparing a string. You know, reading text isn't meant to be the fastest deserializer, but we should be able to make some improvements to make it better where we can. This is one of them. And it also generates an error if there is a field that's not recognized. So what we need to do is we actually need to default initialize obj right here. So that's what we're going to do now, is we're going to do with those new bit field macros and also the yeah, with no bit field macros, we're just basically going to default initialize those things there. So let's sort that one out. Where's the CSON reader? Sure, I saved HTC to some folder and added a path environment variable. When I invoke it from the terminal, I get this error. I took a quick look at the code. I think what the problem is, she asks. Oh yeah, I think I do a ah. Oh, right. Did you have to CD to the path to get it to work? Oh yeah. So, right. I think maybe. Oh yeah, I don't use relative paths from the Yeah, I think those, where is it? Yeah, these built-in libraries have to be relative from that thing in the directory. You can't move this to another folder. Yes, it's the way it's been designed. I think that's on Linux as well. I think it's on Windows and Linux. I think. Because that's just the way I designed it. They have to be... Yeah, maybe it's just a thing I could change at some point. Yeah, it's good to know. Thank you so much. But yeah, that's how I made my I did my Ray Marcher. If you take a look at the screen here. That's just a 2D image. Right. But it's extruded across the Z dimension, and everyone it's actually voxels. I just ray march against the bounds of the image in 3D space. Sorry, ray trace against the bounding box of the image in 3D space, and then I'll ray march into the pixels, and then it will render that. And it's actually voxels because they're pixels, right? That's why you're getting those really sort of like sharp corners. But yeah, so it's a bit fun. That's actually that's one of the samples, I think, but with the HCC logo instead. In the samples app. Yeah, good fun. Ray Martin and voxel ray tracing stuff. Boom, boom, boom. Right, so generate the CSON reader. If it's a strut. So for unions, you might want to do like a different. You might need a tag. You need a tag passed in. Yeah, let's just ignore unions for a second. We will be solving those, don't you worry. So this is where the fun begins. We're going to be going over all of the structure fields, and we're going to be default initializing everything according to the default initializer. So the most simple way is to do obj how many tabs do I want? Just the one. So the first thing you're going to do is you're going to say obj deref whatever the field index is, field identifier is. Then you're going to say equal, and then you're going to do dollar field default value, I think. Oh no, v. That's it, yeah. So that's the most basic one, but obviously it's going to have some extra things, like if it's packed. So, alright. So, if it's a packed one, we've got those lovely macros that we did, right? That's going to be using the, I want to get this right, it's the, right. Yoink. Right, so $ts fi set dereference of object, and then to whatever the default value is of that. For crying out loud. There we go. And that will also be clamped within the ranges because the macro does the clamping. Yeah, it does the clamping. Yeah, it does. Which is pretty sweet. So we give that a bit of a test spin. We're not finished up yet, but it's the basis is for it, and it's good to but yeah, just take a look at the header file. As you see, when we do the sets, it does do the clamping of the value that gets passed in. So we go to the generated C file. Give a reload. We clearly did a bit of a silly. We've got a bit of a case in there still. Give it another. Right, so these should probably be casted into the actual type. See, they do this 0 thing. That's a bit of a... So they're not actually set to anything, it does this. Which is probably a bad idea. If we're going to be building those strings, it should be casted into the actual type. Yeah, they weren't set properly, unfortunately. Sort those out though. I don't delete the other. Damn it. Right, that TS would have been due to some other thing. Huh. The wrong thing there. Right, so where do we do this sort of like bracket 0 bracket thing? Like where are we doing that in the Well, we constructing a string like that. Right, it's not really. Okay. So what should we do here? Maybe this should be actually cast it into the right type. But then if it's a structure, yeah. So if it's a structure, okay, here's what we're gonna do. If the default value is not specified, so the default value is specified, we'll do it this way. If the default value is not specified, we'll do it another way. Did you around to doing the job system? You talked about it 2 months ago on Discord. Skim through the GC talk, but it's not what I'm looking for. Yeah, I just ended up skipping it because it would have slowed me down more. And I don't necessarily need it yet. I'm going to have to do it, and it will be a little bit more work. And it's not really would have slowed me down more. I also don't know if the one that I would have designed would have been as good if I just waited and see what I need a bit more further down the line. I didn't actually do it yet. It would have been a lot of thinking, and it probably, yeah, would have been actually been a lot of work. So I decided to postpone it until I actually need it. Yeah. It's alright. It's cool. Awesome. Rematch cloud shape. Amazing. Beautiful. Oh, I'm in here. I'm playing back. I've been captured. Maybe I'm inside the cloud. This is great. That's cool though. I've not done this before. This is just something I need to learn about. Sweet. Sounds like fun. Cool. At least I know my compiler's capable of doing stuff like that. Thinking about collision culling for my engine. I've used BSPs before. but I prefer to move away from BSP compilers. Do you have a technique beyond frustum culling? Yeah, so there's one that I actually tried. There's an occlusion culling algorithm. It's called like a hierarchical uh, depth buffer or something like that. We actually implemented one in the past. I might go back to that technique, to be honest, when we're next to the renderer. Let me try and find it. I got you covered. So I think it's yeah, I've I might be better off going to my actual where she started doing it. Yeah, there is a VOD channel, by the way. Occlusion. Alright, Pass Henry, he's had a haircut. I don't think that Pass Henry did it here. What's Pass Henry doing? Or was it the original time I did it? Yeah, that's the V2 one. This is when I was doing a bunch of spheres. Oh, yeah. I don't know, I can't find it anymore. Could have swore. Hey, maybe I can find it. Is when Alex Evans presented it at HPC. It was one of the years. No, high performance graphics. That's it. He's done it. He's done a few times. It might have been this one. I remember it being a day 3. It ain't this one. Wait. No. It might have been this one. Yeah, this sounds similar. Sorry, familiar. English. Was it this one? Yeah. Cluster-based culling, I guess. Yeah, cluster-based culling. You could do it for meshes as well. Does it talk about the generating the depth buffer beforehand? But anyway, I'll drop you a link. It's like 21 minutes in. Hey. Did that one wrong in it? Yeah, that's another way you can do it. That's the way we tried doing it. It's cool, no worries. Yeah, that's another approach. That's basically what engines do these days. That's like the current approach. Break things down into clusters, and you render clusters instead of meshes. And you occlusion cull clusters. Because, yeah. And use the hierarchical depth culling technique. So you build a depth pyramid. which you can do by reprojecting from the past frame, or you can render a low resolution version, and then use that type of thing. Or a rough version using simple objects that represent, so there's different methods you can do. Depends on your game, really. But yeah, so that'll work there. So if you haven't got a default value, the whole point is that, so I've got some rules. Right, unspecified default values. So basic values are 0, enum values are 0, vectors are 0. So struts follow their default initializers. It gets recursive, doesn't it? So maybe it should be a function then, so this can end up working. Yeah, because then you can actually call it. Okay. Right. That's okay. Unions follow the type of... Yeah, so maybe we are going to generate a function then. That'd be alright. Okay, so in this case, if the kind is packed, it's just going to be 0. You're just storing 0 in there. Then if it's a basic obj equals there's a dollar in it, 0, right? What else? The rest of them are basically structures or a union. So we'll say strut. What? Sorry, basic or an enum. Wait, what's the enum? Enums are 0 initialized as well. Yeah. Or right. Structures are going to call the default function. So just be default pass in the address of field identifier. So yeah, we are going to end up making this into an its own thing now. So realistically, what you would like to do is also make hey, views on climate change. Try to really avoid politics here, to be fair. One or two times we'll talk about politics, and I'll let other people briefly talk about politics, but we typically avoid it because programming is typically void of politics. Unless your name is Godot, I guess. But yeah. Hey. So hey, Freshen and Rook, how are you guys doing? Default value functions. Right. So you only really want these for struts, right? Struts or unions? Unions probably require an extra sort of special parameter to say which tag it is, actually. Oh, we're going to do that. Well, the tag can just come in as an int. That should be good enough. Oh crap, we forgot about the U64 thing in the... Right, we definitely got to get back to that. Hang on a minute. Yeah, so... Yeah, it's supposed to be something like that. And we've got to really generate some for the vector types as well. So this will generate some for the vector types. And then we can copy paste those, store them in the standard library, or our core library or whatever, the engine. And then so we don't have to hand type them out. Yeah. Well, let's argue over tabs and spaces. Yeah, exactly. Tabs. The tab and space is far more important than yes, worldly things. Doing good. Been watching these codec streams here and there, but not entirely sure what you've been doing. Like, what kind of coding you doing? I do see, but unfortunately, I do not see. Good man. Yeah. So basically, it's a generalized encoding and decoding thing. So you can think of it as like it supports saving and loading to. So we have this custom format, which is basically a C structural file. So you just declare structures and other types, right? Like enums and unions. But you can say like, right, we're going to be targeting files. You can also say we're going to be targeting GPU. So it's a file that gets read into GPU memory, or this is just a file. And you say whether it supports text or binary. Text is not supported on GPU, and neither are a few other things. So whenever you enable GPU, it actually turns off some features that it will tell you about. So when you turn on the file target mode, it turns on another set of features like versioning. So we can do versioning and upgrades. And if you just want to target the GPU, you can just use this to generate a bunch of tightly packed data structures. Like we've got this custom packing format, packing thing. So it does our own bit fields basically, where you can pack an integer down into 9 bits within this range. And it automatically generates the packing and unpacking code for you. So it's ultimately a way to serialize runtime types in memory to binary packed data, or runtime typed memory to text files. And you save that to the file system, or maybe you don't, and you don't need versioning or upgradability. So it's basically that plus code generation. So we code generate everything. So we can read the code and debug it that way versus just versus seeing it all with void pointers. So yeah, it's just gonna be super handy. It was quite a bit to implement. Not gonna lie, but you know, I see myself keeping this sort of system and expanding on it, or refactoring it or whatever, far, far in the future whenever I want to use it again. Um, yeah, I don't really follow AI. Well, okay, I see AI stuff, but it's all just hyping it. Like, I don't see AI. I don't see AI being super revolutionary. It'll get to the point where it'll probably replace jobs, but it won't be proper AI for a good while, I reckon. So I'm not really interested in following it. It's probably just one big fad. Um, there's probably a few people who are capable of actually making AI. Um, yeah, I don't know if we'll get there yet. Um, we're probably at least 10 years off. So I'd rather just be focusing on other stuff that actually matters. Um, yeah, it's lots and lots of money involved. Money, money, money. Yeah, I guess like yeah, no, you've got like Elon's announced his Tesla bots. Um, so there are going to be like things are going to be capable to a good degree to actually like take jobs, right? But in terms of like an actual like being that exists that thinks, I think we're way off that. So I'm just not really interested in following it. Plus, I would prefer if these things probably didn't exist too soon because they're quite disruptive. But we'll see. We'll see what happens. For now, I'm just going to focus on making games and stuff until I can't anymore. No, I can always make games, right? Um, right, so some default value. Oh, shoot. We wanted to put this section headers in it. Text default values. So maybe we'll put the word text default. I don't know. I'll do default values. Screw it. Right, so for defaults, here we go. Code generated. So first thing we're missing is an extra new line. Right, that didn't set this type correctly. So actually, gen dot equals structure field type, and that will work out nicely. Yep. And then let's just give that a regen quickly. Right. Yep. That's all right. So these are okay. These are unions though. We've got to be careful about that. So, or this is a union, should I say? So this actually has to take in like a tag and switch. Um, do, 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 do. Yeah, this is where it's a little bit more complicated. Right, I'm just going to take a quick break and we'll resume back in just a sec. Alright, welcome back everybody. Righty-o. Okay, so these default generation things, I guess let's do this union one. We're going to want to pass in the tag field. So the thing is, the tag could actually be, it could be any size. We could pass it in as a U64. We haven't actually got the tag type in the union itself. We could probably... Yeah, that's the thing. We actually haven't got the tag type. Technically you could end up with two different type of enums here. Which is a bit silly. But it would be a bit too verbose if I did, tag and type, right? But it would be a little bit kind of overload the tag thing though, but you need it for text basically. But if for now, because I can't be bothered to add that, let's just make it pass in a U64. Wait. No, but you need the key. Okay, we're gonna add the tag thing then. Let's add it in. We'll add it in. Which means it's also got to check that these two are the same. They're compatible. Yeah, so let's get into the generator. So where you generate where you parse the union thing, let's look for it in a string. So there's some tags or directives that get parsed. So one's bit field, one's packed, one's root. So we just copy this one. So I want to say if it's not a union, which means I do have to update the docs as well. Tag directive is only able to use on a union. So what you're going to do is set the tag field. Tag type is an enum. Something like that. So how do we find types? It's like type, table, find. The identifier would be whatever is in the next thing along. So right. So where do I do tag in the past? So open bracket, isn't it? Yeah, what were the other ones doing? Well, those weren't doing it, that's why. So another directive, open bracket, Maybe a new line. No. Yeah, new line. Yeah, just read until then, trim it. So you got the string, that's the identifier. Yep. Not find value, I want to find a type. Ident_type find. There you go. So they'll use the hash table, we'll find it, give you that back. So if that is null, I think that's the thing, right? Yeah, it can return null. So tag directive type cannot be found. Is not declared. Is undeclared. Int casted string size string.data. So okay, so that will go. Yeah, so I need to make sure that it is a enum. So if it's not an enum, type kind enum. TK is a type kind, but must be an enum. So this is where you're going to have to use the context-aware printing and put in the type that we want to, that TK to be populated with. So that'd be the tag type. Boom. Cool. So that should be the extracting code, and it ensures that it is an enum, right? Now, anytime that we generate the key, yeah, so anytime we parse the key, we must, so okay, so before we do that one, the tag field must be parsed if there's a union and there's text mode, right? So what we need to do before we carry on anything is we need to say if it's a union, union and type strut tag type equal null. Then what you've gone and done is made another error, which is saying that missing. So I think, let's look for that tag thing again. We're saying it's missing. Oh yeah, and text. No. Yeah, missing. This is the one I want. So maybe it's like that. Right, so missing tag directive for union. So I could just do $tk $ti for identifier to specify the tag enum type. You only need this as text format is being used. So we'll do like a union type name $tag enum type name. Right, something like that. So we'll just put a reader in there like that. And we need yeah, that's what I need to do. I need to set the type. Yeah, the format thing, that's the one. Gotcha. To type. Cool. Right, so the next thing we need to do, let's go to the, is that these keys, their enum values must come from the enum that you've specified here, right? No biggie. Yeah. So when we process the key, key does a find value, right? So what we actually need to do is there's another find value. Yeah, type find value. So we actually want to do it with type. So that would be type. No. Structure, which is still a union. Well, which would be a union in this case. Because struct and union share the same thing. Because they're basically just a bunch of fields. Fields are just processed differently. Strut dot tagged type. So that would be the enum. Search for the value inside there. In TK. See, in this one, I've combined format args with my custom context-aware formatting, but I didn't do it in the other. I maybe could have made another function which did it for the code generation. But yeah, so be TI. So we'll just put in gen.format type strut tag type. Right. Cool. That's pretty nice. So they're the checks we need. Oh, one more check. When you have you specify the tag, right, inside for the field, you say, well, the tag field is this one. You need to ensure that type, bear in mind, it could be a packed type, so you got to get the enum of that. Those match, right? So that's not too difficult. We already do it here. Make sure they are enum. Okay. So we do another check. If t equal t not equal to enum. No, enum, where is it? Structure field type. No, tag type. Yeah, structure field type would be the union. So that'll be the tag type, that's it. So what we're saying, and the not of if it's a packed type and it's equal to the unpacked type is this tag type. So tag field this, type is does not match the union's tag type ti, something like that. Yeah, so we'll chuck that in the format thing. Oh yeah, cool. So that's all the checking, I think, and it will actually bring that new tag type inside the union. So when we do that default value now, right, if it's a union, you can put the tag type in here. So I might do E because I've not done E yet. I do tag, right? Just put that in. So E would be strut tag type ident. So that will, yeah, so then tag will be declared if it isn't a union, right? Would the contents be different for a union? Yeah, it'd be a switch, wouldn't it? So you'd end up doing a switch statement with a case and picking something to initialize it to. And I guess it will default to 0 if, well, maybe it's uninitialized if it's not found one. Yeah. So I think these are two distinct things, actually. So actually what we're going to do is copy paste this whole thing. And right, so the union one is going to, for the default value, you go over all the fields. We'll do we've done this sort of like hash thing before when we do the reader. CSON reader. It's this one here, right? We go over all the and generate this sort of case. Wait, it's not the hash. It would just be the actual enum value itself. Right, we won't need a default. Let's switch it like that. We'll just copy the switch code though because it's handy. So you put the switch in there. You switch on tag. And the rest of... Ooh. Right, so you get the structure field. This would be the tag key. So we don't really have a thing for that. Although we could just do I could do a lowercase k, make it a custom print format thing. Wait, it's a structure field thing in it, so it'd be a, huh. I could do a K here, capital K. Hey, Devastated. Not doing bad, my friend. Not doing bad. Yeah, just gonna be wrapping up on this encoder system thing. Well, what I mean by wrapping up is doing the final stream on it. It's gonna get like it's mostly finished where it is, but I think doing more streams on it is just probably a bit counterproductive from here on out because it's a bit in the weeds. But we'll be moving on to new systems on Tuesday, so we're actually starting on the a very simple asset system just so we can in the future refactor the code and know where we use the asset, where all the assets are, so we can change the API around if we end up doing that. So we'd be doing a very simple asset system which will just load from files within the asset directory for now. So we'll just load from stuff in here basically. So we'll be starting that on Tuesday, and then moving on to some other things like probably gizmos. They'll be quite simple, and maybe, yeah, I think that was it. Gizmos, and then maybe some UI related stuff because we're actually going to be building a first editor soon. The plan is to start building the material editor in by November. When we start November, we should be building the material editor. Which is a very basic one, hence why we're starting with it, just so we can get a feel for the whole system, right? Building the UI, saving out a material file, loading that into GPU, and just get a feel for the things we've made already before we do a more complicated level 1 and model 1. But yeah, they're the yeah, that's what's going on. Besides that, doing pretty good. How are you doing? So K would be gen dot strut field key. Now what was key again? Keys are actually just a string. Oh, it's an unknown value. Right, and if we get the ident, that's the string. Boom. So if I just do a bit of a fk, that'll get us the key. And then if this is the one, then we just call the default value for the it's whatever the default value is for that. So it will be kind of like this. It could be a basic or it could be a strut, but it can't be packed. So we would never get that. So you would do something like that. Extra couple of tabs in there, and delete all of this. Right, so that should be the union sorted out. It's a bit of faff, but hopefully it's alright. Just give it a rerun. Tag directive is missing. I didn't save the file, so at least the error works, right? That's good. Go to run. No. Oh, from the database file. Right, so the database did not have it. Let me correct the database for a sec. This is the database file where it's basically a mirrored copy with some explicit values in it. You shouldn't really edit this, but type is undeclared. No, it ain't. Did I get my things wrong? Right, Boolean logic. If it's not an enum, right, Boolean logic again. Segfault, okay, what are you saying? Shoot. Damn it. Right, so I think what's happening here is that we weren't copying over that field now. Is that in the merge code? No, I can't see it anywhere in here. So it seems like in the database at least. Give it a reload. Right. The union. It would have been red. Did we not store it? Definitely stored it in there. So what's the merge not doing then? There's something the merge is not doing. So in that case, it would have been an existing structure union. It would have done these checks. Yeah, we also need to put a check to make sure that the things. Oh. You could probably not change the tag type as well. Some more rules. Right, so text files, you're forced to upgrade the version if you change the tag or key names. Yep, we need that check in there as well. Okay, sounds nice. Awesome. Doing good, thanks. The move starts in about 2 weeks, so that's very nice. Counting down days, nice. Very cool. Awesome. You'll be moving in end of the month. Nice. Awesome. So right. Yeah, so this only exists for text, doesn't it? So what we need to do is have that check. Something like this. Oh. Yes, this one is merging the type. So only if it's a union. If source type kind equal union. Source type structure tag type. Right. Destination type strut tag type. So we're merging, yeah, checking they're equal. If they're not equal, we're saying probably use the destination type. We want to say that there is a tag type mismatch. In the database, it is E, right? That was it. It was the E. It is TE. So let's change it, up the version number, blah, blah, blah. Right, so we're going to probably trigger that in some cases. Wait, I don't know. We're probably not going to trigger that, but anyway, we'll put this one back to that. So for some reason this disappears, it doesn't carry over, which is very bizarre. Because it must parse it. So let's run it. Okay, so let's put that back and see where it's seg faults, because that's weird. So oh, that should have been okay. I know what's going on. So it's not right. So we've clearly not handled the serialization side of things of the database file. So we save the database file. We're simply when you save out the type, and the type is right. So it's a union and text. Or maybe you just do if type str tag type. You print out the tag type here, so you just got to TE $tag T, that'll do it. So I'll print that out there. Right. That's good. So when we do the actual like tag, when passing the tag for the default value, we forgot to remove this. So if structure this side of the code, if union this side of the code. And that was where the seg fault was coming from. There we go. So now, finally, oh, we can go back to the C file that gets generated and reload. Go to the top. Here's the default stuff. Right, we missed a, but here it is, right? So the tag type comes in. It's a little bit wrong. It needs the version number. But yeah, you know, it does the, you know, depending on the tag, it will default initialize the union to one of these, right? Nice. That was a bit of faff, but it's getting there. Do you think there is a benefit of a custom config format for programming language instead of using something like TOML? You know, I'm doing my own. It's CSON instead of JSON because I think, you know, I quite like C syntax. You know, you have the type in there, right? It's not just a bunch of like when I'm reading this back, it's like, well, it's that type. You know, I've got the fields in there. Supports arrays. In the future, if I wanted it to support enum'd arrays, it still kind of follows C syntax. You know, I can always support that in the future. So this is the reason why I'm doing a C-like version. You know, plus it supports trailing commas and People typically just use JSON and do a subset of JSON because JSON supports all sorts of things like data objects and that. Um, but yeah, I just prefer to do it this way. Um, but the benefit of using JSON is that you get to use other tooling that uses JSON. Um, you know, but I don't think I'm going to really want to do that. Text location better for error messages. You can do that in any format, right? Any format you parse, you can do better errors yourself. Oh, they lose that information, do they? Oh, okay. Doing a custom config format for a programming language instead of something like TOML. Oh, I see. Right. So you're talking about like how Rust does it with its thing. But Rust is not really that's the package manager, right? Are you talking about package managers now? Yeah, it sounds like a package manager thing, really. The thing is about TOML is, from what my understanding of it, is that it's not as capable as JSON is. Like, there's some things that you literally cannot do with TOML, I think. It also feels quite. It's basically like an extended ini file, TOML. But yeah, you can use whatever you want if it's just a package manager, right? I don't see any benefit to it other than you get to control exactly what it does and how it works. And that's a big benefit, really. The custom format designed specifically for your program's needs is a big win. But if you think you can get away with a JSON file, you know, it's easier onboarding that way. People just understand JSON, right? Or whatever, TOML. You're reading that JSON and XML. Yeah, XML is definitely slow because it repeats a lot of text. JSON is slower because you've got to decode text-based numbers into binary numbers. And you've got to take strings with escape sequences and turn those into strings without escape sequences. So there's extra allocations involved, whereas with binary, it's just as is in memory. So there's some reasons why. Probably more, but they're the top ones. It does. There is a JSON 5, which is like this thing which I thought initially was a new version of JSON, but it's actually not. It's an extension. But people typically support it these days now. But JSON 5 does support unquoted keys. It supports other things as well. Yeah, keys maybe identify a name. And trailing commas. But yeah, so JSON 5 is an extension that does it. Well, pro buff. What about it? Hey, Wajida. Hey, coffee. Put a bunch of YAML. Oh my days, YAML. Yeah, YAML. Yeah. Right. It's all right. Um, so the thing is, what happens if it's a union? You can't have unions in unions. That's against the rules. So that'll be all right. Yes, just got to get that type name right. Bit of TG. Need a bit of a TG. Where's? Right. So the generated name. So let's do lowercase e. So what does a G do? Puts the version in it. Right. I'm running out of alphabets. Hey, yanked. There we go. What? Fantastic. Take that for a spin, and we end up in... Finally, a union, default type, based on a tag. Oh, right, so we're nearly finished here. We just got to sort out these ones. These are the packed types, they're not working. And then arrays, I think. I need to figure out the arrays one. Did I put arrays in here? I think I should have. Yeah, so arrays in that. And then we need to generate quickly some of these vector ones and store them in the standard library in the engine code because yeah, I don't have to keep regenerating those. I want to share them between all the different generated code. How much generated code have we got at the moment? Okay, just a few hundred lines. That's good. Right. So this one needs to be corrected. These packed things. So this structure. Right, it's generating a strut. The packed ones are a bit off because this wants a yeah, this needs to be the packed type instead. So let's get in there. It's already there. Structure field type. So right. It's only wanted here. Right, context-aware printing and global variables, amazing. This creates a few problems sometimes. Okay, so here we got using our super lovely macros that we finished up today, which set bit fields accordingly. Yeah, so hopefully the compiler will recognize this and just zero the whole strut, but it's just text. It's just for debug stuff typically, so it should be all right. So these are all the default values here. We still want to test them, so luckily we can change things around. So here's our structure that we're looking at. It's missing like the array one and some others actually, so we should look at those as well. But let's put in a default value here. Let's put another default value for for another packed one here. This be ent type dragon. Ah, it's strings, damn it. And because it's strings and you got versioning, it's going to be a real mess up. It ain't going to work. If I run it, so these are actually quite bad. These needs to be, shoot. Right, these need to be prefixed with a version number, actually. They're wrong. And then because of that, these need to be prefixed with a version number. But we could do that okay here, but the problem is with the default values, is the default values are just a string. So because they're just a string, we can't actually, well, we could always take the string and look it up and make sure it exists and then turn it into a versioned one. It just takes some extra steps is all. It's possible. It's possible. But yeah, that one got translated in okay, that's good. Yeah, so let's sort these out. So dragon, right, so we generate the actual types. Oh, pro buff. Yeah, let's a pro buff and the other thing, what was it called? Flat buffers. You know, they do code generation and things, but I will want to work on GPU as well. And I want it to be a GPU. Yeah, working my custom shading compiler, right? So I want it to be a cohesive system that does sort of packing and unpacking. And yeah. So. But yeah, also protobuf does like variable length. So with mine, I ended up going with a decision, which I didn't want to go with initially, but all binary data is represented in structures. So all of the packing is done directly with these packed types, and these will produce bit fields basically, but it's manually packed bit fields with, you know, shifts and ands and ors. And this works on CPU and GPU, save into files, reading from files. Yeah. So whereas protobuf and flat buffers, I think they use variable sized things and they actually pack them down into bits, which has an encoding cost and requires extra things. So by doing a custom thing, we could just basically take pointers to things and you know, decode it manually as if it's actual structures and then turn it into the runtime types and things like that. By literally reading the whole file in and casting it to a pointer. But we do code generate the text file ones though. Encoders and decoders that way. Yeah. So this generating the actual type. Generate the types, enum. So this value, I should really probably do a capital G here. Um, hmm. Enum value. Oh, I've already got G. Lowercase g though. Right, lowercase g. Oh shoot, that ain't it. Here's the lowercase g. Nice. Rerun that. Reload. That ain't it. There's a VG somewhere else? What? I don't use a VG anywhere, so it's clearly a copy paste bug, right? Put that G back. Yes, it's meant to use the enum value, it's not using the right one. Okay, so regen. Cool, so now they've got the prefix of the version number, which creates problems that we want to solve. So that's how they should be, right? Because if not, you can't do the version upgrades, right? You declare your own function, which does the version upgrades between two buffers, right? You have one buffer that you read the whole file in, and you cast it to the pointer of the root type, and you manually traverse it and convert it. You output a new buffer with the new version. So when we do like dragon and all this stuff, right? These have to be the right ones. So whenever we do these switches with enums, we've not really done them with the version, right? So we've got to do those two. So for the default functions, that's one of them. Case FK, so that's key. Right, so when I say K, structure field key ident. So that needs to turn it into the enum. Oh, it's an enum value. Right. Let's get rid of that line. Don't need K anymore. So gen dot format enum value equals structure field key. Yep. Then that'll be VG. That'll convert that one over. Then the other times when we do it is actually in the when we're doing the CSON reader, when it's an enum type, we return that, so that needs to be a G instead. So that means generated identifier. There's only so many alphabet characters in different cases. So reload, and that should, there we go. So we've got the V0 dragon. This one still failed, but here when we read the text file, or we read the enum, get the identifier, hash it, switch on the hash, figure out which one we got, and then return the appropriate enum there. Cool, so those two have been handled. The one that hasn't is default value, since this is a string, but we can still handle that. So we're going to do a bit of processing for the default value. Where's defaults again? That's bit fields, defaults. So your default is an enum. This is when it's specified. So this is when it's not specified. This is when it's specified. So what you would want to actually do is say, well, if it's an enum, we're going to find the enum in the actual type that you've got, and then yeah, print out properly basically. So it should be possible, which is good. I'm happy that it's not too bad. So gen.format enum value. So we do like a type find value. Now it may not actually exist. So we should probably have done this when we actually parsed it up. So let's look for this, right? So we'll call our default value enum value. You know, oh, default enum value. I'll do it. So whenever we parse it, which is here, we go right. If the structure field type kind is an enum, or type kind equals enum, sorry, equals packed. And structure field type packed unpacked type kind is an enum. Super fiddly. If that's true, you want to get your enum type, find the value, and put it in as the so you get the type. Alright, catch that drive stayed. Good to see you. Have a good start to your work week. Hopefully see you Tuesday or something. Yeah. And if not, it is type. So many dereferences. All the dereferences. Something like that. Rightio. So, then we simply just go default value enum, type find value, pass in the type, then the identifier, which is going to be default value, and then we just ensure that it does exist when we actually parse it, so we can put the error on and line number basically at the place. It's off by a few places, but it's good enough. So let's just get that in there. Oh, so we are simply just saying, well, ensure that exists. If it don't, we say default value this. I could say $FV does not exist in the enum ti. I could say tkti, but anyway. Get rid of the hint. No hint needed there. And actually that extra new line is wrong. We didn't do that. Those extra damn new lines in there. Okay, so we don't need anything, so we can probably just squish that up like that. Then we want to say the context we're printing that the type needs to be the enum. Then the field, structure field needs to be structure field. And that will work out nicely. So if we, or when we get to actually doing the default value stuff now, here we don't need to define value anymore. Instead, we just need to set it to whatever structure field default enum value is, and then it will just be a v lowercase g. That should all work out nicely, like so. So we go to the test, give it a reload, find that default value. That's still messed up. Why? Ah, because this is a packed type. Interesting. Right, if it's packed, then if packed enum vg. So if the unpacked type is an enum, we'll get the default values an enum. So those may or may not exist. Oh yeah, if it exists. Yeah, good. All right, let's give that a give that a go. Boom. Excellent. So now that makes a lot of sense. Let's try it for the one which isn't an actual packed type as well. So let's do a bit of checking. So let's do default that to ent type pig. Right, so I got the pig there. That's good. Where's the union? Right, so we're missing union, we're missing arrays, aren't we? So we should sort those ones out too. So which ones we got? We've got new field, we've got coordinate, we've got health, strength, range, ent type, and ent type 2, ent type 3. We've got defense, we missed the array, and we're missing the union. So these are not being handled. So arrays. Right, before we move on, is there anything about the docs that changed that we've added? There's that tag thing. Unions need to be decorated with the key directives and the field or the union. The key and tag directives, yeah, so I'd have to change. And the example. Tag and key directives. So you'd need to say ent type. What else got changed today? What did we do? The bit fields, that was it. So those packed types. So the pack types, what this init doesn't get generated anymore. Instead, you also get some setters. So they're actually yes, they're not really. Yeah, so that should be like a define. There's a getter. Then there's some setters as well, so you'd get a set value. Yeah. Cool. Alright, that'll do. Right. We missed a couple of things in the bit fields as well. This is what I also forgot. So when we generate the bit fields, let's go to the, there's two things, right? We didn't use the U64 for moving stuff around. Oh, that could be a problem for GPU though. There's another thing with, right. So what was it with these generated bit field things? I've forgotten it already. No. Right, let's fix the actual problem that we know, and then we'll probably remember it. Damn it. Right, so the problem is if the bit field gets shifted more than, so if the bit field word type is a U64, these need to be casted into U64s. Hang on a minute. Is that right? No, it might be okay because, because whenever you're reading, you're using the U64, so that'll be okay. Whenever you're putting a value on, it's whatever the type. Oh, shoot. Yeah, this value needs to be casted into whatever the word is. No. Because the word could be less. The word could be less. The bit field word could be. So after the shifting has happened, that's when you cast it. Yeah. After the shifting has happened, cast it to the word, and then that'll be fine. Yeah, macros, man. Yeah, I want to get them to work on my custom C compiler. You don't have pointers on GPU, so I've got to use do it that way. Oh, that's the other thing as well, is we're not clearing the bits out on the setters. It's a bit ugly, but it's what you got to do, unfortunately. Um, right. So in the bit field generation on the, is it just the getters or the setters? Yeah, the getters are fine. It's just the setters. So whenever we do a value, we got to make sure that it's casted into the bit field word type. No kidding. Because if you get a U64, you could you could if you shift more than 32 bits, it will promote it to an integer. Although it will promote your type, whatever it is, to an integer if it's not an int already, or un. Do the shifting and then overflow. So it needs to be casted to U64, hence why you need this cast. If your word type is a, you know, a U64. So where the shifting matters is the stores. So it needs to happen here. So I think that's a P $PB. Yeah, bit for word type. Good. So that's where one happens. Then for the remainder ones, which can spill over into the other words, you do it there. All right, so let's take a little look at the generated result. It's not the context where printing, is it? Whoops. How will we do it, eh? You prefer big files and long functions? I kind of like this style of code more and more. Awesome. Yeah, I've actually created more files in this project than I have in others, and it's probably just because it's a bigger project, but you know, I do want to make my files get bigger rather than smaller ones. You know, I only do single compilation unit at the moment. But yeah, fewer files, please. Easier to navigate, easier to find stuff. So all my graphics is just in these files here. I've got some internal headers. I might get rid of these in the future. I'm not sure. Just put at the start of the source file instead. But yeah, because these are typically quite small. These guys. Just do one file per subsystem. But there's now that I've got code generated stuff, I'm putting the generated stuff in different files. So there's some generated headers sometimes and generated source files, but these will get included into other files. Yeah, typically you don't touch those anyway. Yeah, I don't know. It depends on the project, right? Where you want to split, basically. What tricks do you do to do very fast navigation around the source code? So I'm in Helix right now, and I just do a space then F, and it's a file picker, and I can just search for the file that I want, and I know what it is. There's also ways of doing, if you do it with a slash, you can do a global search. So you can just search something and it's fuzzy. So I could just be like print, and instantly it's just giving me every print. So there's things like that. And I've got controls to jump back to the previous, jump back to the next file. That's what I do. You can do the same in NeoVim. Let's configure it. Need another drink soon. Yeah, so I need to just split this line up. It's a bit of a bugger. Should have made a different print format thing. Maybe future Henry will clean it up. I did just join this one back up actually. I remember doing that today. What a bugger. Alright, print format. Up to about there. Cool. Right, so run that. Get back in the generator side of things. Right, so cut. Oh, PP. I'm gonna say TB. That one meaning to change the context thing. You know, I'm gonna put it in a string manually. It's a bugger, but AO. Type. Actually. Basic type strings, type strut. Amazing. So it's just one. Saved by a C string. Beautiful. Now what to do there? What? They don't compile. Cool. So cast correctly, and voila. There you go. So that's good. The other problem you got to solve is you actually have to you have to clear the bit field before you OR it in. So that's the problem with these setters, is they have that line in there, but hopefully that you can get optimized away in some cases by the compiler. So we've got to do those. So you've got to get the mask of the thing you're trying to write in. So you've already got the mask and that's here, right? That's shifted left by 1. So you want to get the mask, do the shift, and then not it. Yeah, so you can pre-work that all out. So basically you take your, now my laptop died, charger in. Right. Yeah, so you got to do, I guess I'll just do this sort of like hex thing. So you take your mask, you shift it by the shift, and then you knot it. Oh, we need the destination bit filled in there as well. Alright, let's try that out, see what goes on. Reload. Let's print out as a full integer, which is not because we're using the bite-sized ones. Got to be careful. So there's a level of precision. Wait a minute. If you're clearing... Oh yeah, don't worry. You're just clearing the one you were trying to ore on just now. That's good. My problem is though... So here this has been the Visual Studio. I'm still using Visual Studio at work because it's just... I haven't translated over to it yet. You know, I like modal editors. It's a preference for me. I like being able to navigate around by using basically shortcut, like every key is a shortcut on the keyboard, and then when I want to enter text, I go into the text enter mode or the text edit mode, or the insert mode as it's called. So it's definitely a personal preference if you, but you can always give it a go and see if it's your thing. Just download it, give it a go, see how you find it. Visual Studio is a lot more heavyweight, but you'll still have to use it for debugging probably. And Helix has got a few little things that it needs to improve on, but if they don't, but they're very small things. But yeah, so just see how you get on really, and just evaluate it. I still need to try and use this at work. At work, I still use Visual Studio because I've recently switched over, and I want to make sure I'm not counterproductive, you know, by switching to it. Yeah, so it's looking alright. It's just the precision. So I think if I did 2 there, what does that do something? I think you can do a star, and then when you do a star, you got to pass in a number of bits. The number of bits that you pass in would be bit count. No. Where's the multiply by 8 thing that I've seen in the past? This thing. Yeah, but it's hex though, isn't it? So 4 bits per... So will that be a divide round up? No, it won't be a divide round up because it's always divisible by 4. Well, that didn't work. Hex precision. But I want to do it with a star though. Did I do it the wrong way around? You could do it with a star. I think it comes first. That dot star, it comes first. Maybe... Oh, width. Right. Maybe it's a dot star then. Oh, hey Tim, how's it going? Thank you for the raid, sir. How's it been? How you guys doing? Yeah, we're just working on a encoder generator, so we're just code generating basically text. Um, we're taking our sort of like custom C-like file which declares a bunch of structures and turning that into code that serializes text and deserializes text, and also other things like packing integers down into a certain number of bits and things. So just finishing up really on the code generation side of things. But yeah, that's about it. How did stream go? Well, you can say that you're gonna. Well, when you say you are going to use a future shader, can you create a 3D game only using future shaders? How do you render triangles? Oh, so um, the way we do it is we ray trace. Um, we're doing ray tracing basically. 3D, you do ray tracing if you don't want to use triangles, or ray marching. And then with 2D, you can just do SDFs. Really, that's another way. Holy cow, these job systems are very complex, and the concepts are not for the implementation. Yeah, I think there's like work stealing and things like that, isn't there? It's like job stealing. You can have different queues that are shared between different job threads and stuff. Yeah, it does get quite complex in some cases, but you can just do a simple one. Oh, we're doing well. We spent 10 hours trying to untangle a huge, huge mess. Oh, amazing. Fair play. Was it by any chance GPU related or maybe to do with some computer graphics? Because they're typically huge messes, GPUs. Um, but yeah. See this precision thing. Let's try and hard code it because I'm bloody confused. Let's put in like a 2. Oh wait. Yeah. We're crying out loud. Why ain't it working? Store. Seriously, why ain't you working? This is just so damn weird. I'm reloading it, right? Oh, did I not reload it? I reloaded it. What? Um. Hmm. Precision definitely comes before. Same with strings. We could try 1. Right, let's do the without the star, without the dot. Sorry, don't want to work. Crap, am I doing wrong? Um. Let's put a big old number in there. How do I tell if my test works? Well, I should just see it. Have less. I'm trying to make it so it only has as many bits as it's needed for the type. So this is a U8, these bit fields, because we're testing it in a very, yeah, so it should have reduced it down. Shoulda. Bloody weird. Why? Let's do a big number. Let's do 32. So we just rerun the code generator, right? And then this is the output. There we go. Look at all that damn padding. So it seems like it can't truncate. So it's always the full-on damn hexadecimal, right? There must be something else we can do. Some do a hex. Hexadecimal floating point, bananas. Yeah, so we need to somehow get it to 32, big number. Yeah, it seems like it's adding. Well, that was width, right? Did I? So yeah, so let's put the dot there and see how differently that behaves. Right. It's padded it with zeros for some reason. Oh, okay. Right. That makes sense. So let's bring this down to 2. And it's not gonna do it, right? Yeah, bugger. Alright. Probably because it has 1s in there. That's why. Right, so if I actually cast that into the right type, which I can't. So I've got to like take the bits out. Right. Where's the number of bits? We'll call it a word mask. So yeah, I think it's because it contains bits, it's going to do it. So much indentation. Yeah, it's just the way it happened. It's code gen code, you know, it's allowed to be messy because it's just generating strings and the strings are meant to be clean. How's it going, Sully? How are you doing, sir? Right, the mask is there. Yeah, what I want to do is generate based on the number of bit field, like that one. Right. So that and it with the word mask, it'll work. So that's the number. Right, and no one knows the precedence of C, well, some people do. They me. Bit number divided by 4, because there's 4 bits per hex digit. And that will be good enough. Oosh. Finally. So, did we do this right? Bear in mind, I've got to do one for the double check for the other one down here. For the trailing, for the if the bit field value goes over 2 bit field words, we've got to do it again. So that's just the same logic, I think. Right. So we're clearing out the bits. This one writes to 7 of the bits, right? This is a U8. So we clear out, except for the first bit, we clear out the rest of them. And then we put the value on there. Then this one is saying, well, we write to the first 4 bits of bit field 2. So we clear out the first 4 bits. Just like that. Cool. So I'm glad we fixed those problems. We get back to actually doing the CSON stuff, which is the custom C like JSON thing. So the next thing on the list was the default values, where we code gen. Right, we need to make sure that these default values all make they're all handled properly. The ones that aren't are these built-in vector types. These need to be code generated and then copied into the standard library because I can't be bothered to type these out manually, right? We've already got for loops which write out all this stuff. So we're just going to copy paste it and sort it all out. And then we'll just delete it. So we'll go if type table types. If the type is intrinsic, so sweet. If type is intrinsic and type, well, I'll do it. Nice. Off you go. Right, give that a regen. Reload. Right. Shoot, we need to generate the close. Righty-o. Nice, so we should be able to copy these and just, well, we've got to get rid of that and just dump them in the standard library and never see these again. But they'll just be there. Well, yeah, because we'll have to hand type out these vector ones, or these matrix ones though. That needs to be a 1. That'd be alright. I'll put a string, right? Maybe. Just watching the world burn down, okay. Yes. But yeah, how's your project going along, Sully? How's the Vulkan going? Are you volcaning? Rightio, so we're going to just quickly regen those again, copy paste, throw them in the standard thing. We probably want to generate the function prototypes too, that'll be another thing. So this is an I instead of the G. G does the version number prefix, which we're not wanting for those. Right, so let's do it again quickly. This time without any content. Do that like that. So we should just be able to copy those into the standard, or the engine's encode.c file, rather than being generated every file. The wrong one. All right, here we go. So let's get going with that one. We copy all that up to the vectors, yoink, hop into encode.h. So basically, we're going to want it for, here's some default functions. Default values for CSON reader, code generated code, right? So they're all there. And we'll simply just do the same thing again, but for these, just get all those vectors in there and those matrix things. Hop into encoder.c this time. Below text reader, we'll just dump them in there. And then copy that lovely section header. Dump that there like that. Nice. They're all looking good. The only things that need to be changed is that the quaternion needs a identity. That's because the specification that we've written in here specifies that if a default value is not specified, then it's going to use the default value of the type. And for quaternions, those are identity. And the matrix is identity and transform 3D is identity. So, right, this one is going to be incredibly wrong, so I'm just going to manually fill it in. We still need to handle array types properly. So, f32 times 4, 1, 0, 0, 0. 3 by 3 matrix in it. 1, 1. Cool. And then translation is 0, 0, 0. Might as well just be explicit about it. Cool. Yeah, so with the transform 3D, which has the translation scale and rotation separately rather than being mushed together, that one is going to use the default, and that'll work out all right. Wait, scale. Identity scale is actually is 1, right? Because you put the 1, 1, 1 there, right? And that's scale. Cool. Nice. That will work out nicely. So, go back to the code generator and we're just going to delete the code we just copy pasted and hacked together, which was purely for the intrinsic stuff, right? Because now we got them inside the core library itself. So let's get back to the actual ENC file. The generated C file. Reload. Right, now we're back in business. So what is this? Was this one complaining? This does exist. What's going on? It's declared. This should be included in, yeah, it is. Which also has, it's not been saved. Right, there we go. So that now shows up good. So we're still missing the union and the array from this type here. There's an array in there of code, and there is a union here, which has to be default initialized based on the tag type. So we still need to generate those correctly. Shouldn't be too bad. Right, I'm just going to take another quick break, get another drink, because I'm run out of that. And then we'll wrap up on those two things, and that'll be the default values stuff finally done. When we do our reader, we can then just initialize the type to the default value before we attempt to read any fields, and then it will be initialized. They'll be initialized even if you don't include or don't parse that field in from the text file. Be pretty sweet. Right, so I'll be back in just a minute. Let's put the tunes back. All right, BLB. Hello guys, welcome back. Mr. No Idea, are you still there? I have a question for you that you avoided earlier. I'd like to ask you a question, sir. So yeah, array types are being missed, and so the union. So let's do the union because it's easiest. We already have it here, and I know what I'm gonna do exactly. So in the code generation, for the default value things, right? If it's a strut, if it's a union, right? If it's specified, yes. If it's unspecified, union, we need to pass in the tag. So the tag field, context web printing. Where's the tag? Do I see the tag anywhere? No. So we might need a new one. So that gets you the tag field. And that gets passed in. Yeah, so I guess I'll do a T. Hey Voodoo, how are you doing? Welcome, welcome. Tag ident. Right, so it'll be a obj f $ft the tag. I think I accidentally quit smoking. Interesting. Great. Aren't you young? You started smoking young then. Crazy. That's cool though. Very good. Yeah, smoking's like, yeah, real bad. Very popular in the UK. Vampire Survivor, like, have some cool projects to work on the semester. Amazing. Vampire Survivor, like, a new genre. And co-op tower defense survival game for Java. Okay. Interesting. Java game dev. Are they both going to be in Java? So this is actually for your uni course, isn't it? Right. Get in there. There it is, the union. Damn it. No member named ent type. Well, it's because the ent type is actually a bit field. Bum, 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 bum. So, what you have to do now is be like, is it a packed type? Oh, and if it's a packed type, if structure field tag, so I get you the tag field, if that type kind, all those dereferences, you can't go wrong, is a packed type. If it's packed, you've got to do the pack thing. So the pack thing would be something like this. So T instead of the I, because I get the tag field. Well, yeah, no, I do need to do it that way. And then because it's the packed one, it doesn't need any. You need to put the type back to type. Wait a minute. Crap. What am I reading? That's a big bugger. Right. Well, you can make a local variable. Call it man, it sucks. Maybe we can make another thing for it. Structure field. This. See that S isn't get the snake case version of the type. I'm looking to see if there's a way to get the snake case version of the type in here. There isn't. Thankfully, no. This one is C++ and any paradigm. Right. Strange. I guess they're trying to get you to diversify your understanding in these things. That's cool. Nice. Pretty sweet though. You're making it in a team? A team of people, or is it just by itself? Oh, how am I gonna do this? So if I make a local, yeah, I must make a local. So somehow, so you put the field. Well, so it's the tag type. Man, this sucks. Super sucks. Right, so tag type, structure field tag, you get the structure field of the tag. So with that information, you could then say structure, sorry, field identifier, and you can call it, sorry, field data type, field identifier. Field identifier, something like that. So you extract that into a local variable, then here you're simply using that local variable, so it's be ft. Man, that was complicated. Generated C file. Right. Crying out loud, what have you done? Close though. G, that'll be it. Generated. Getting close needs the equal symbol and get rid of that stray bracket. Right, so it makes the local, and then I'll just put the local in there for the tag type. So that's the union done. Right, so default initialize a union now. But my concern, oh wait, it says deref in it. Yeah, cool. So my concern is those if you have multiple unions with the same tag, it's gonna have problems, but you should never do that. So if that becomes a problem, I'll fix it. But yeah, this should be okay. Right, so now it's the union done. There's still arrays. So we've got an array declaration within the thing here. Then it was to follow the rules say arrays. Well, arrays are not on here. So arrays probably follow the rules of their um, hmm. Fair play, Mr. No Idea. So I wanted to ask you a question. Maybe you can save it for the Discord. But the question was, you said you want to make an engine now. Is this going to be specific for a game, or are you making like a general engine of some kind? But yeah, feel free to respond to. If not, I assume you will respond in the Discord. It might be a bit of a lengthy answer. C++ game is 4 people, but probably I'll write most of it. Java game is 2 people. Yeah, probably most of it. Most students don't know how to program. Most just don't want to learn it. Oh, bit strange. So you're working in a game development course, is that right? Sounds about it, doesn't it? So I guess they want to be game designers, right? Is that the idea? Or do they just want to be blueprint developers? You're still working on the version thing, right? Yeah, the encoding system. Just trying to wrap up on it really. Getting close, but this will be the final stream. I'll do the rest off stream because it's getting kind of nitty gritty right now, and we've spent enough time on it on stream, and the gist is kind of understood. Uh, yeah, it's pretty close, just nitty gritty stuff. Starting with general stuff, keeping minimal scope with most bang for the buck such time functionality. Fair play. Hmm. Right. So I guess you want to make a 3D game at some point? Is that the idea? To be like a 3D engine? No, it's a computer science course. I just pick games as projects because I like games. Nice. Oh. Yeah. Computer science. Hmm. It's interesting. Yeah, people do computer science, but they don't want to get into programming or do they want to do hardware? Like what's the endpoint for those people? I did it because I wanted to program, and I didn't get taught that. So I don't know where. Like you just learn about stuff, right? Yeah, I don't know. I guess you want to be like a system admin, maybe. Yeah, there's no point in 2D, fair play. Well, I guess you can make an easy engine for other people to use, but yeah, 2D you can just roll your own engine for the actual game every time. Really easy. Oh, hackers, yeah. Just running exploits that someone else made. You know, hacking. Hey, Majestic Mac, how's it going? I need to have an editor, be able to create custom scripts, custom data, be able to extend rendering sound and packing. Right, nice. Yeah. See, I remember Mr. No Idea. He was one of the people that told me that you never make a general engine, Mr. Man. Look what you made me do. Game an engine, huh? But yeah, right. With a cyber security specialization, but it's basically a joke. One when you pick that as a specialization, guaranteed for you to pass in uni. Ah, interesting. Yeah, uni's always a bit weird. Well, I'll certainly go the direction after the basics. Yeah, yeah. Obviously, in 3D, there's a lot of stuff you can share around, and yeah, with this one, I've been thinking about this game with that engine thing. I do like, you know, I've ended up making an engine folder where the common engine bits go, and I think if this engine is going to be specialized for this type of game, where it's like an RPG top down, it's got a specific renderer. But if I ever want to sort of move it to a if I want to do another game, this engine folder is probably going to come over straight away, obviously, and then I'll probably just nick bits from this game layer. Um, so yeah, I do quite like this approach at the moment. I think it will work well. And obviously the engine layer can just be changed for each game as it wants, right? It can evolve into whatever the next thing needs to be. It doesn't have to be completely general for every project. It could just be drastically changed if need be. And doesn't have to support all the old games as well. But you don't need to make compromises to get that. I don't know about Voodoo's case, but I have some experience in my country because I just want to get into uni for a diploma, but not because they're interested or want to. School inertia slash conscription evasion. Right. Yeah, some people get into IT for the money. I find that a bit of a weird one. Or programming for the money. Not because they want to do it. You can make code as separable as possible, avoid spaghetti, and you can make good parts for. Yeah, you can take the parts between projects. Yeah, definitely. With general purpose engine, a modular design is the way to go. Yeah, I don't know if you guys saw the ARM machinery engine. They had like plugins and stuff, and they like interfaces, all these function pointers and stuff, and that looks like quite crazy. So I think there's a degree of modularization which is probably good, but I think the way they did it was like so crazy and over the top. So I think there's a line there. Got to be careful about. It seemed like a lot of boilerplate basically, and going through function pointers and yeah. Yeah, I do agree though. Splitting stuff up, doing that separations of concerns which people over do as well. But separating modules out into their own things, having layers between the GPU API and the graphics API, you know, yeah, just good programming, keep stuff, don't have the graphics know about, sorry, the GPU layer know about the graphics layer, and don't have the GPU know about the networking or whatever it is, right? Doesn't make any sense. So arrays, they're the other one. So when you have an array of values, maybe you can iterate over the array of values and just basically repeat the same thing. So we missed out on the docs. They're base type default initializers. So the thing is about the arrays is you can have arrays of arrays of arrays of arrays. Or we could just say arrays are unsupported. Or we could just say arrays are zeroed. So we just say arrays are zeroed. It's really inconsistent though, because the rest of them like follow. Like if you have struts in there as well, you've just buggered the thing up. An array of struts. So we'll try and do this, right? Base type. So how are you going to achieve that? Right, okay, that's good, that's good. So if you take the you got to do recursion, right? So you would go. So basically, this needs to be made into a function, and it just recursively gets called. That's it. But with the but then what do you put? These need to be like commas instead or something, and this. You have an array of unions. That's going to be weird. Arrays. It's possible though. Let's just try and see if we can do it. So these will have to be commas. So then we'll print out a tab, and then print out a new line, and that here. All right. There'll be a function called like generate field default value. You pass in the structure field. among other things, which we'll figure out as we go along. All this gets taken and plopped down up here somewhere. Yo. Radio, what works? Right, I need a bit of an F as well. File F. Right, then we just recursively call that boy. So this is the default value is specified. So the default value is specified and it's an array. We just set it like that. That could be, that's definitely gonna be problematic if you do like an enum or something, right? We'll cross that bridge when we actually need to solve that problem. I doubt we're gonna need it for a good while. So when it's unspecified though, like an array, sorry, for an array, then we go over all of the, you get the array type. Index 0. If the type is a variable length array, that's another one. But we wouldn't have initialized the, maybe we have to allocate some memory somewhere. Right. In a second, Ardillo, I'll just read your stuff. Yeah, so the type is definitely an array. So the thing is it a variable length array? So if VLA right, so we'll handle this one in a bit. Let's just sort out the non-variable length array, which is the easiest. Array dot elements count. Basically, you keep calling this thing, and you've got to probably put in a bunch of new lines. Hang on a minute. How are you going to do the So that's another thing you can't have is an array of packed. An array of packed value doesn't make any sense. So we need to be careful about arrays. Huh. Kind array. Alright, where do we set it up? Here, right? No. What search for that? Okay, maybe because that's a special character, the angle bracket. So there's a check. Right, something like this. structure field type kind. Right, so you don't want packed because that will be very problematic. So we say cannot make an array of a packed type. That'll be a good one. That will make this code that we're about to do a lot easier. So just run over the same function and wait, structure field. What is structure field doing? I want to be careful. So we've got to pass in the default value, the default enum value as well, and the type. The rest, oh, there's a tag as well. Yeah, maybe we just pass in the structure field. That should be good enough. Maybe this is fine. So we just got to make sure we put make these all right. These might have to be array literals somehow. We'll figure that one out. Right, let's catch up with the chat. I guess I need to be specific about what I mean with do not do a general engine. I refined my ideology. Get an idea about what you need in the future so you don't box yourself into a limited solution for no reason. But do only support what is needed and be done with it. Do not overscope. Do not go on a tangent to try and cover all possible uses. Yep, refactor it when you need more uses. In essence, do only what you need to do, but in a clean way. Do not worry about the future when it comes to it. Yes, yeah. In some cases, though, you will need to predict the future. But yeah, don't over predict it, definitely. If predicting the future causes you to do like months of work or whatever, years of work, then obviously don't do that. Modular design is the anti-performance by nature as opposed to specialized design. Modular causes redundant communication costs and limits possibility of inter-optimization, which is important. Yeah, I can see that. Specialized design leads to spaghetti code. It's about doing the right call at the right level. Both extremes are not good. Cool. Yeah. Yeah, definitely a fine line between it all. Man, arrays are difficult to code gen. Because if we go to the C file here, we can either put it in a loop. Wait. Yeah, we can just make a loop. And we can make another pointer. we could put it in a loop, make a pointer to the data that it needs to write to. And then that will mean so this here. See, these sort of like But yeah, if we just had a pointer to the data, we could just increment the pointer and just keep reusing it. But the only problem is in the code gen, how will we achieve that? These bit filled ones, or these packs types, they're not capable. Sorry, they're not compatible with array types. So it's mainly just these things. Like either this is going to have like an array part to it. So maybe we could do another print format thing where you do like $array index. That can work. Or yeah, I think that's the approach. So these are packed. Packed. Not packed. That's the tag, isn't it? Yeah, the tag will never be an array. Right, so I think what you would need to do... See, the problem is the multi-dimensional arrays then. I guess we won't have those supported, and if I need them, we'll add support for them in the future. But that's a bit of a bugger, actually. These default values. Maybe we could have just said default values are just 0. And just be done with this, because it's a bit complicated. I'll think about it. Yeah, we could just say default is 0. And that would probably be alright. You try in GCC's extension with dot dot. I didn't realize they had that extension. Yeah, I'm trying to... Yeah, that's correct. Set all of the elements within a range to the same value. Yeah, I didn't realize that's an extension, but yeah, I don't really want to rely on extensions really. Yeah, maybe 0 initialization is okay. I don't know. Like a zeroed transform is pretty bad. But you could always check for that and be like, right, identity it. Yeah, that's interesting. Yeah, I don't want to support extensions where possible. I'm using one at the moment, but that's only because it's a feature in C23 to come. But isn't that a... Wait, C array... initializer. I think that's actually a feature, isn't it? I remember seeing it somewhere. Or is it a there was there a case where I saw a dot dot dot? Okay, maybe not. Fair play. It's not, is it? I'm not sure what I'm getting confused with. Maybe it's the... Right, okay. There's not a thing. Yeah, maybe we make the default values 0, and when you parse some text where the field doesn't... So you mean your enums have to be 0 is initialization. The only ones that concern me is the transforms, right? If you get a matrix saved out and you add a new field, which is a matrix, to a text file, or the transform to a text file, you add it, it will be 0, it'll be zeroed, but then you just check. If the whole thing is 0, identity it, right? So there is ways around that. It's a bit much, I think. Also, it's more code generation in this default value thing. Maybe we just get rid of it. That would make the system more simple, and then we can get rid of all the edge, because there's a lot of edge cases making it a string. Yeah, I might get rid of it. I want to think about it now. Yeah, so we may or may not fit. Okay. So I think I'll leave that. I'll think about it more tonight, basically. So off stream, over the next couple of weeks, I'm going to be finishing up on this sort of CSON reader. I think it's actually there. I wanted to add the default value. There was another thing with where it didn't support arrays. So I need to add that in. But it's getting close. And then I need to generate the CSON writer. So it's just the other way around. And then I would need to do the binary encoder, like having support for actually writing out binary files. So I'll work on this off stream just because we kind of get the gist of what's going on. And it'd be good just to get started on something else. So go to the plan. I think it's game tech plan. Boom. So we've done these two now, right? The entity system and the encoder system. You know, the initial plan, it wasn't going to be a big old system, but I decided the big old system was probably a good idea because it helped me out later on. So the next one is the asset system. We are definitely going to follow along with what these notes say. We're just going to have an assets folder we load from. There'll be an API. We can just say basically open up an asset, get me load the whole asset into memory and give me a pointer for it. The asset might not be ready right away. So it's a sort of, the API will support like saying you want it, and then later on you go, is it ready? If it is, great, get the data loaded in. So we'll have an API for that basically. And then we can move on to probably doing gizmos and and then we'll probably move on to the material editor. And so I might be doing some UI color picker widget as well, but just basically build a material editor so we can change colors of some materials and keep track of them, save them out and stuff like that. Yeah, so hopefully the text stuff actually works by then. It should do. Should be all right. But we can always fill in with temporary data until the encoder thing is done. Right. I'm going to bail now. I'll think about this off stream. But yes, the next stream will be on Tuesday, Thursday, and Sunday. Tuesday and Thursday is about about 3 hours ago on Tuesday and Thursday, and then about 4 hours ago on Sunday. No worries. Catch you later. Good to see you, Clarissa. Find someone to raid. Raid Lost Miles. Let's go. Right, have a good start to your work week, guys. I'll see you all in a future one. Catch you later. Bye-bye.